Before everyone was talking about transformers, GPT, and alpacas, we were discussing neural networks, machine learning, and artificial intelligence. But perhaps today, people have lost the most important part of this revolution, what it takes to make good decisions. So today I'm talking to Cassie Koserkov, who helped define a new discipline at Google to help humans make good decisions. She's provided guidance on over 100 projects and trained over 20,000 Googlers in statistics, decision-making, and machine learning. Cassie, can you talk about your journey and what it was like creating a completely new discipline at a company like Google?
I started out playing with data when I was very little, and I got over data so young that I just could not take this pronouncing data with a capital D thing that's going on these days very seriously at all. So I kept looking in my teens for where could something important and valuable be, and I'm looking around for a major. I've gone to college age 15, so I don't know what I'm doing. I took statistics as my easy A, right? Like that was the logic back then of this small creature. But I kept thinking, like, where is something that's the most valuable thing that I could study? And I was pretty into economics. I took an economics major because on day one, the professor said, what is economics the study of? Turns out scarcity. It's not about money, it's about scarcity. Scarcity in all resources. Scarcity continues no matter how much money grows. So I thought, wow, scarcity, that seems like a really important thing. Scarcity is always going to be a fact of life. I'd better study that. But then expanding that and thinking about what are we actually going to do in light of that scarcity? Well, that is manage it, optimize it, make decisions around it. Resources are scarce, time, money, whatever you like. And I began to realize as I got more and more into studying disciplines that touched on decision-making and human behavior, that it is through our actions, our decisions, that we impact the world around us. That's really the most important thing. And I also began to understand that how your life turns out boils down to two things. All the random luck stuff that you cannot control by definition, right? All the things out of your control, and then the things in your control are just the quality of your decisions. So what could there be that's more important to study? Now, that said, what is decision-making? Good decision-making is hopefully turning information into better action. And so if you're going to be serious about studying decision-making, if you believe, like I began to, that it is the most important thing in the world, the best thing that you could learn about, well, if you're serious about it, then you can't only focus on the actions and the framing and all the traditional stuff from the previous century. You also have to contend with the fact that information these days, it may be going and taking it in through your senses, looking out the window, having dinner with a trusted advisor, something like that. But it could also come in electronic form, and it could come in massive electronic form. And the decision sciences, the traditional ones, don't prepare a decision maker at all for dealing with the data piece. So you have to get into the hardcore data sciences to really be able to be a modern decision maker. So for me, decision making is the most important piece, but I so absolutely passionately believe that the data component has to be part of that. And when we approach the data sciences, we have to take it from a decision and action perspective. So which decisions will come out of this? How will this help us take better actions? And if we're automating at scale, that's taking decisions or actions at scale. And so how do we reorient all the existing bits and bobs that we get from different disciplines and put them into one discipline that is focused on one thing only, and that is making better decisions, turning information into better action in any setting at any scale. So that's the modern decision discipline that I'm very proud to have championed.
That's amazing. And I do think that machine learning and AI have definitely made the mechanics of data sort of easier. So has machine learning and AI been something that's been part of decision intelligence at Google, or did you experience an evolution as a result of sort of the rapid developments in artificial intelligence?
Well, the data sciences always had to be part of it, of course. And then how do we think about the data science umbrella? So for me, data science is the discipline that has underneath it three subdisciplines: statistics, analytics, and machine learning / AI.
Mhm.
And the difference between these three disciplines really boils down to how many decisions the decision maker knows they want to make before they begin. So if you have no idea what decisions you might want to make with the data set, don't be creating hypotheses. You don't know anything about it. What you need to do is take a look and get oriented, situated, inspired as quickly as possible. And the discipline of doing that is called analytics. So no decisions before you begin. Analytics is the one for you. What if you want to make a few important decisions under uncertainty? Well, what is the discipline that deals with making decisions when you have very little information? You wish you had more, and you have to make that bridging leap between what you know and what you wish you knew. That's called statistics. So that's for one or a few important decisions under uncertainty. Now, what if it was many decisions? You wanted to automate your decision making. That one, again, under uncertainty. What I mean by under uncertainty here is you can't just look up the answer with a lookup table. So there, if you're using patterns in data to automate your decision making, because it is essentially decision automation, then you're going to go into AI and machine learning. So in terms of proof by cases, if I wanted to cover all the cases, no decisions, a few decisions, or many decisions, that's all of them. So there had to be the many decisions component. We couldn't leave that off. And that is, of course, the machine learning and AI piece.
That's pretty amazing. And I do like that you said that your easy A was the statistics class, because I know that personally, for me, I think I passed statistics because the teacher felt sorry for me, honestly. So just because it was a different math altogether, it just didn't make sense to me. And I think like if it doesn't make sense to you immediately, it seems like a little bit harder. So that distinction is really important.
When you bring that up, I know that you wanted this podcast to be about something else, but I'm almost tempted to go all in on holding forth about statistics education. Statistics education is such a mess. And I want to say, on behalf of statisticians, because I went and qualified and became one, on behalf of statisticians, dear public, we are so sorry. We are teaching you the wrong thing. And the reason is, this is a complicated tangle. But what you learn in your Stat 101 course is not designed to be the most useful thing for you as a citizen. It's usually not great for data literacy. There is this traditional tendency in our discipline to say, we are going to train you under the assumption that you are going to one day take a master's and a PhD. And you know what? One day when you're in your master's class, you'll be like, aha! Oh, I see now why we had to estimate the standard deviation, why we had to show two parameters both estimated simultaneously, and we got t-tests. That all feels like witchcraft to students. It's not well explained, and it's not there to be a useful tool right now. It isn't typically. And what people go and do is they are given a bunch of hammers, and they go and they look for nails. What you were actually taught is some incomplete, fingernails worth of technique, which you should presumably have developed because obviously you're going to stay and be in the statistics major. Now, I'm going to say a very opinionated thing. Now I don't speak on behalf of all statisticians. I just did the sorry on behalf of all statisticians. I feel like we ought to do that maybe. But now I'm going to just give my personal opinion. This whole session is going to be my personal opinions from here on out. So don't assume that I'm speaking for anybody else who's not me. So the way that statistics as a discipline goes, it is the science of changing your mind under uncertainty.
Hmm.
And in statistics, the biggest sin is coming to the wrong conclusion rather than not coming to any conclusion at all. So if you think about the logic of traditional hypothesis testing, in there is we have some action we're happy to take under ignorance. That's called the default action. Out of that, we get our null hypothesis. And the idea there is that we've imagined the worlds, all the states of the universe in which we want to take that default action. And we then say, we're actually happy taking this action. It's fine. We're going to do it. We don't mind. Unless the data force us to change our mind, unless the data talk us out of it. But we're actually happy with this, doing what we were going to do anyway. So if we learn nothing from the data, what we write down is we failed to reject the null hypothesis. It's actually learning nothing. You learn nothing, and you know what we're going to do if we learn nothing? We have this contract that we've signed. We're going to do our default action happily, cheerfully. We know nothing, but we're going to do what we said we would do when we know nothing. If there is a strong signal in the data that makes us feel ridiculous about these worlds that we've described, about the null hypothesis, and therefore we feel ridiculous taking our action, then we have to change and do the other thing. So by design, if you think about it in classical statistics, by design, learning nothing is okay. We don't mind. When we come to some conclusion from data that's more than learning nothing, we had better be quite confident, if you will, that we've done the right thing, that we've very carefully followed techniques, that we have stated our assumptions carefully, and that the data are yelling at us, yes, 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 change your mind. So as a discipline of preferring to learn nothing rather than learning the wrong thing, it might also be a discipline that's like, we prefer not to have beginners around here, if you will, right? Because what are beginners going to do? They're going to try to use the tools they got, and they are not these big, grumpy philosophers that you're supposed to grow up into as a statistician. So we don't want them running around making conclusions.
I think that your class sounds a lot more interesting than the class that I took. So I think I would have done much better. I
have a stats class where, to celebrate learning nothing, to remind people you're supposed to learn nothing from data sometimes, I would have us all jump up and down to point out we learn nothing. That's a good thing. That's allowed. Because if you insist on learning something from every statistical analysis, you will learn something stupid. So the first art is being okay with the situation where you've learned nothing.
Yeah, I love that perspective of like Mythbusters that always said that even like a result that seems like a bad result, it's actually a good result because that's data, and all data is good data, even if it's not what you expected. I think they had this one episode called Bull in the China Shop. And in that episode, they let a bull go and they constructed, I don't know if you saw that episode, they constructed this china shop and they thought the bull would just go straight through all the china. And instead, the bull very gingerly navigated very carefully. And no matter how much china they added, the bull very gingerly avoided it to its best of its ability. It was only through an accident that the bull would actually topple something over. And that was completely contrary to what they thought was going to be the result. So, and that's really where you get to test your hypothesis. And I think like some of the stuff that you were mentioning regarding your class, I think would have made a much better class.
You'd be surprised how painful statistics is to people who actually love mathematics. This is a funny one too. So I have a graduate degree in mathematical statistics, but I came for the statistics. I mean, math is something that I was good at, but I love the uncertainty and the art of it. And what a lot of students who really liked being math majors experience when they get to stats grad school is that it's a different game. Suddenly it is creative. Statistics is fundamentally creative because of all those assumptions that come into the jump from what you know to what you don't. Like there's no magic that can take what little you know about the world and turn it into all the stuff that you don't. All we're doing is we're taking what we do know, putting it with assumptions, and those assumptions are subjective, creative, and then coming out to reasonable conclusions based on that combination of what you're willing to assume and what you do know. And that is so painful for those who want everything, all the ducks in a row, everything to work only one way and to have only one answer. So, not only is it a new mathematical approach, but it's not even that kind of thinking. And it takes many years to develop that sensitivity, I guess.
That's so interesting. And I think that that goes to sort of what I'm talking about next, which is you have degrees in economics, statistics, and neuroscience, and psychology, even. So, how do you think that each of those fields impacts some of the work that you've been doing with decision science?
Oh, okay, so first we have to understand that the words around here are tricky. Decision
That's
science
true.
is a job category, both decision science and decision intelligence. I think if you would look at LinkedIn's data from
Mhm.
before I started talking a lot about these things, you wouldn't see a lot of these titles. So I'm very proud to have influenced a lot of adoption in those directions. But I also have to fess up to decision science not actually being a singular thing usually. In the 70s or so, maybe the 60s, the decision sciences referred to the social sciences and the managerial sciences that dealt with decision making. And the reason that I find the decision sciences to be an unsatisfactory collection is that it's a collection of stuff that's been around for long enough that it feels okay ignoring the data side of things, which is why decision intelligence is the upgrade that we need. Because if you went for traditional decision sciences, you'd say, all right, great, we will have at most some, small spreadsheet or pros and cons tables or those types of things. Rarely do we talk about muscling up into hardcore statistical inference or AI or even the art of analytics at petabyte scale.
Mhm. Yeah, so that's really interesting. Last week we had Sadie St. Lawrence, and she really got into how she's had a lot of experience working with, different fields, neuroscience, psychology, even some of the same sort of backgrounds that you have had. And what made it interesting was that all those things are relevant to the field. And yeah, I mean, it's all experience a sort of evolution because of just a lot of the recent developments with
Mm-hmm.
AI, ML, and
Yeah, right.
over time, I think, yeah, over time, I
Yeah,
mean, it's been a big change.
yeah. I think maybe I should answer your question dead on, actually.
Yeah.
So you asked how these different disciplines all play into what I do. I remember a college counselor telling me that he was concerned I might never get a job with this crazy bucket of stuff I was interested in. And I was sure that I was interested in one thing and one thing only at that point, because this wasn't during my freshman year where I was still figuring it out and being very gung ho about my statistics easy A. But later, when I wanted to learn about biology, neuroscience, psychology, um, sociology, economics, political science, philosophy, all these things, and it didn't make sense as a major because it wasn't one. And that for me is such a mistake, I think, that the world is making. To insist that if you want to learn one of the decision disciplines, that if you want to learn about decision making, that you have to take a full major in one of the traditional decision disciplines and then learn all the not decision stuff. So I have entire large chunks of coursework in those majors that I didn't care for at all, that I just had to suffer through to get to what I cared about. Take pretty much all of macroeconomics. No offense, economists, but I could flush it. Like, I have a degree in economics from the University of Chicago. That's considered pretty good. I did not want any of those macro courses, like maybe just a little bit, like a little quick read, skim the topics. But I wanted to focus on decision making. So I loved the auction theory, the experimental economics, the behavioral economics, the industrial organization, labor economics, those kinds of things, because they were closer to the decision disciplines. And even a whole bunch of those, I could have gotten the distilled decision pieces instead of going and pursuing the whole course. So never did
Hmm.
I feel like anybody was trying to teach me specifically about decision making. I really had to take lots and lots of coursework that felt irrelevant. And look, I love having general knowledge. I read all kinds of stuff. I just don't confuse it with, what I'm trying to optimize for at the
Hmm.
time. So it's important to read history, but history may not be, a relevant core course for, say, a biology major.
Hmm.
Like, read the history, but might not be should maybe not be your required 101 course. So I felt that way about all of them. Like in psychology, I could totally leave developmental psychology, for example, the how the infant brain develops into the adult brain. That is cool, general knowledge stuff, fun, but not super relevant. So I had to go and suffer through all these separate degrees to get those core bits that I wanted. And then I had to go and find core bits in other places, in other degrees, without taking that full degree, sometimes even taking a graduate course as, like extended study to try to learn that stuff. And I just wanted one major. Come on, can we just have one? And so that's what I would love to advocate for. Can't we just have a decision intelligence major? And if any academic institutions are interested in starting an institute, I'll just pitch that I would be very happy to co-found that. So yeah, shoot me a note. But we need more of this. We need more focus on what I believe is the most important skill. And now, just to stay on my little rant, is it a skill that we take seriously? I mean, when was the last time that you hired somebody, audience, you hired somebody and you wanted them to be good decision makers, and at no point did you check their resume for decision skills? And how would you check? No one puts anything there. And did you give them any kind of test? Did you check if they're a good decision maker, or did you just hire them and hope? And what if this is like a VP or SVP type hire? How do you know anything about their decision skills? Do you even have a way of telling whether they're a decent decision maker? And so much rides on that. We don't take it seriously as a society. I'm not seeing the actions that I would want to see that say, we're serious about this. We actually believe that this is, okay, there's a bit of art, but it's also a science, and it's a skill, it's a craft, and it's something that someone can intentionally practice and get better at.
A lot of times when I was in school, there are things that I took that I didn't think would have a huge impact, but they were at least sort of point of references for me. So I took a film class, I took a logic class. Again, like exactly what you said, the easy A class. And I'm not sure how I got a B in film class, but somehow I managed to get a B in film class. But some of those classes were interesting because they just gave me like a different perspective. And I think that having that broad kind of spectrum of experience, even not necessarily knowledge, but just the experience, gave you like a perspective where, oh, I remember this from, this field. I think that, something that I may have heard. Now I know to look for, maybe expand on that knowledge and look for that. So talking about how you think about perhaps interviewing people who are, going to be decision makers, you had this great opportunity to teach over 20,000 people at Google in decision making. So what are some of those biggest misconceptions that people have about effective decision making?
One of the biggest misconceptions is that decision making is just something that you're good at, that with no intentional practice, you could just expect, because you make a lot of decisions your whole life, that you automatically get the skills. And unfortunately, decision making is one of those tricky areas where the world doesn't send you good feedback necessarily. And so it is very easy to learn the wrong lesson from your actions and your decisions, meaning that you are actually potentially likely to make worse decisions later rather than better decisions as you go along. And that should scare you. If this is the steering wheel for your life, I mean, life boils down to two things: luck and the quality of your decisions. And if the quality of your decisions is going down over time, isn't that terrifying? And yet, people just leave it. They're like, it's fine. No need to invest in myself. Coming from the perspective that I have now on this, I just can't understand why somebody wouldn't want to aggressively invest in their decision skills.
I always think about how many horrible movies are made, and you wonder, how do you get so many bad decisions from people?
That's why the course that I've just recorded with LinkedIn, it does 3 chapters. The first chapter deals with fundamentals that everyone should know, regardless of technological proficiency or skill levels or other stuff you might know. Chapter 2 goes into the upgrades. I think of this as the mech suit, if you will, for the decision maker, and that's where all the modern data disciplines come in, and they're sort of upgrades to your decision-making ability. And by the way, at no point in that course am I saying that you have to become a statistician, but there are many out there. Just hire one when you need them. What you need to know is when you need them, which is covered in that course. But then we get to chapter 3, which is relevant to your statement about bad movies, which is, it's all good and well being the person in charge with all your upgrades, and you've learned all this stuff, and then Suddenly you're in a group setting, and all kinds of things go differently in group settings. That's the most challenging sphere for a decision maker, and quite often it is the mismanagement of the group decision process that ends up with those sort of situations. But coming back to other misconceptions, so one is that decision making is a skill, it should be learned, that there's a process for managing it. When we play with data, when we use data for something, when we build with data, automate with data, decide with data, that is something that has to be led by the people in charge. Whoever it is who's actually fiddling with the settings and saying what the assumptions should be, saying what success looks like, that is the person who is the actual decision maker. And the big misconception is that it is possible for somebody who is a leader to go and hire a bunch of nerds with PhDs in data-related stuff and then say, here, you know data, go make some magic. And the misconception is that when that all happens, that the person who hired them is the one who made the decision. Actually, the decision responsibility was passed, and the decision comes from however that data is then processed and arranged towards decision making. So the misconception is, who is the decision maker? Quite often, you have the people who should have the business expertise, the wisdom, they're in absentia, and you've got the numbers person who has potentially no business savvy, making really big decisions, and that should also make you quite nervous. So the appropriate collaboration, who does what when, is a very big piece of the process upgrades and the courses that I taught at Google.
Some people see it as making like a fairly structured and calibrated process and take into account like all the data available, while other people seem to do well with a more spontaneous sort of process, maybe an intuitive approach. So where do you think artificial intelligence model fall within the spectrum of this decision-making algorithm?
What artificial intelligence allows you to do is to scale up your decision-making. That is what is happening in the foundational piece. What people don't realize, all of the instructions when you're building a foundational system, whether it's something like Lambda, large language model, or it's a typical image recognition system for enterprise grade, or speech to text, which I'm sure you will use to generate captions for this podcast. Behind the scenes, when you're building the big system, there's a lot of huffing and puffing and code that gets written. All that code is there because the tools are icky to work with. It takes a lot to get them to accept your data, to reliably process it at scale, talk to the right data centers, etc. In terms of the actual instructions that are being given when you are applying these algorithms to your data, there are only 2 instructions behind the scenes, right? They're all covered in these barnacles of unpleasant coding that you have to do to get it all to work. But really, in terms of human instructions, there are only 2. And those 2 are: succeed on this objective using these data, go. Those are extremely squishy, subjective decisions that get hidden in all the crusty stuff of making it work. And because it gets so hidden, people have this way of talking about AI as if it's an entity, it isn't, or as if it's thinking by itself. And we anthropomorphize all kinds of stuff, right? Like if your toaster annoys you, you talk to it like it's a person. And if you stick googly eyes on it, it's going to be worse. You'll talk to a sock puppet or a pet rock. The whole robot thing, that's like pet rocks on steroids. We pay more attention to it because it's got eyes painted on it. But really, what AI is all about is being able to communicate your wishes to computers instead of writing all these instructions that say, do this, then do that, then do that, then take this pixel, then find a circle, and then do this, and then do that. Instead, you say, here's my objective. Here's the examples I want you to learn that objective from. I want you to find patterns in these examples for this objective. Go do it. Very, very subjective, highly subjective. And people don't realize that. That is where you need so much decision skill, because you have just taken all the thoughtfulness that would have gone in traditional programming into writing 10,000 lines of code or 100,000 lines of code. Some human has to think of that. Even if you as a developer, you install someone's package, still some human thought about that. Some human decided that it was a good idea to do these things in this order. Now you skip all of that with AI and you get your task done by saying essentially, this is what success looks like. Here are the examples I want you to use for it. Just like teaching, right? We teach people in two kinds of ways. We either communicate with explicit instructions or we communicate, here's a bunch of examples of me doing it. You figure out what the pattern is, you learn from that. So what machine learning and AI let you do fundamentally is they let you communicate your wishes to machines in this second way. And at its core, it is a thoughtlessness enabler. Because sure, you're huffing and puffing on actually getting the tools to work, but behind the scenes, in terms of how you give your instructions about the task, right? Only those 2 lines. This is what success looks like. These are the examples you should use. Super, super subjective, but condensed down to 2 instead of those 100,000 lines. So this is a thoughtlessness enabler. This is both the most exciting thing about AI and the most terrifying thing about AI. Because the idea that you as a developer, instead of writing all those instructions by hand, can say, hey, look at some examples. That's great for automating your personal stuff. Here's how I want this thing to work. I give some examples. Now the thing copies them, and now I have a nice tool that accelerates me personally. Amazing. Thoughtlessness enabled there is great. Then I can spend my time thinking about other stuff. But what if I have the ability to do that same kind of thoughtlessness on a Tuesday morning while sipping my cup of coffee and half looking at cats on Instagram? I belch out some objective and I say, hey, use those data from that vendor. We don't know what that vendor did, but I'm sure it's fine. Data with a capital D, right? I'm sure it's all good. Use that and then serve that system to 1 billion people, right? What could possibly go wrong? The fact that we can now thoughtlessly automate and impose our wishes at a great scale on many, many people, that's the most dangerous thing about AI systems. So we'd better re-inject that evaporated thoughtfulness, right? We had better, as decision makers, step up and say, what on earth am I trying to do here? How do I responsibly teach? It's just like with a human student. If you knew the only way to get them to follow your instructions to do your task would be to carefully come up with perfect instructions, you would get those instructions really carefully right. I'd like to submit as exhibit this fun YouTube video I like of a dad who is teaching his kids how to give instructions, and they're supposed to tell him what to do with bread, a knife, and peanut butter. And will he actually get a peanut butter sandwich? That's a really fun, instructive video to understand what can go wrong with AI, and also the difference between explicit instructions, what it takes to program by explicit instructions, versus all the things that we might take for granted and assume a system knows that it doesn't. But that's traditional programming. What that father is teaching his kids there is, don't assume the system knows anything. In order to get your task done, you have to come up with perfect instructions of how to move the knife. Yeah, exactly, that's the one. How to move the knife, how to put it into the peanut butter, and so on.
This is great.
Yeah, it's great. It's lovely. And so that's traditional programming in a nutshell, right? And in order for those kids to be able to program their dad, they must understand the task. They can't do it otherwise. But with AI, you could just say, here's some examples of peanut buttering happening. This is what success looks like. Now go figure it out. Thoughtlessness is available. But again, when you are releasing at scale and you're affecting a lot of lives, you have to put that thoughtfulness back in. Think about how you would teach a student with examples. It would matter what textbooks you give them. Just because the textbook says mathematics on the front cover doesn't mean that it's going to turn them into a PhD mathematician, right? It could be mathematics for the 2nd grade. Don't just judge a data set by its cover. What's inside there? It's the responsibility of a good teacher to understand and think about what examples they're actually using to teach their student. And if we still treat data like it's a little bit magic, and we're like, oh, there's a data set, I'm sure it's fine, all kinds of things will go wrong. So yes, you are able, theoretically, to say, that data set, I'm not going to worry about it, but it's now your responsibility as a leader to go and do your due diligence and understand what examples you are teaching your student from, what's in the actual textbook. And when you're setting exams and you're saying, this is what success looks like, and you're incentivizing your student to learn one kind of way versus another, again, you should think about that. You should think about what kind of student you want. So all that evaporated thoughtfulness that would have been in the giving of the instructions and would usually have taken a lot of thought by a lot of people, is now gone. How does it come back in? The decision maker has to put it back in. That's how it comes back in. And so AI, in some sense, is the automation of decisions. And so the decision maker's got a lot of responsibility. And as a decision discipline, it starts to use all of them. Everything from the psychology of your users and how you think about making sure that everyone is fairly represented at the beginning of your project, and before even choosing a target for automation or thinking about what success would look like, you're thinking about how this would interact with real human users. How would you measure success when the system that learned from examples is operational? How would you know if it works properly? Right? You're going to need your statistics skills coming back in there. You need some kind of process for iterating towards a solution. And a lot of the time, what you're doing is you're tinkering semi-haphazardly, hoping that some patterns will be found that will be useful, that you check statistically, you make sure they work. But how do you do that without taking infinite time? That uses the data discipline of analytics again. What's worth doing? How do we frame it? How do we think about what success looks like? That's all the decision disciplines right there. And how do we think about optimizing? How do we think about incentives and limited resources? Right? That's classic economics right there. So all the decision disciplines now come back into being behind the control panel for AI.
There is sort of a concern with the current state of LLMs that some of the mechanics of how they do their work can create kind of unexpected results. I think one of your more viral posts was on the ability of LLMs to be unconcerned with the truth and perhaps err on the side of pleasing the user, which can be, something very dangerous to decision makers.
From the perspective of the builders of foundational models, so think of your Googles or OpenAIs, they are approaching the creation of this system as the kind of decision-making problem that I've described. What should it do? What does success look like? What should the system do when it's operational? What data are we going to train it on? And what is an efficient process for getting from that data to a model that might do what we're looking for? That's from the perspective of the builders of these large systems. Then they package it up and they hand it to users. Then something else is happening. Now it's an app, or it's a system, or something where the user doesn't see the data that went into it, doesn't necessarily see what it was built for, how and why, all the subjective decisions that turned into why it is the way it is. And now they take this thing and they use it as a tool, which is fantastic, right? We are a tool using species, we're a tool making species. I'm so happy when I see us making progress and getting rid of drudgery. And, I remind myself that we could all be, hunting with a spear and living in mud huts. And yet we're not. We have this miraculous exchange. We're not even in the same city, Ray, but we've got this miraculous exchange thanks to tools, thanks to technology. So it's great that we have them. We should also use them responsibly. So a decision maker coming into this, understanding I'm being given a tool, how do I use it well? That's a different problem from how do I build the tool in the first place, which is the AI bit. In fact, there's not that much AI going on. People talk about AI after that point where it's packaged up as an app available to you. But in some sense, the AI part is done. What you should think of instead is this is a tool that's got pretty cool capabilities that tools didn't have before. Don't worry about if it's AI or not. When you think about it as AI making decisions, it's like, oh, it's a robot, an entity, a thing that thinks. It doesn't think. It is designed to do fancy text completion, sequence to sequence completion, following certain rules, trained on certain data. And when you prompt it, what you are saying, what you're doing essentially is you are shining a flashlight at the part of the data set that it has been trained on. And you don't even know what that data set is, so you're making a lot of guesses, which is why prompting is a bit of an art. Now, as a decision maker, your first mistake would be treating this like an entity that thinks for itself. It does not. It is a tool. And so it is on you to make sure that if you're going to trust it for anything important, that you don't just trust it. Now, people keep asking me, Cassie, why would you trust AI? And I go, I wouldn't trust AI. I also wouldn't trust humans. I wouldn't trust traditional software. I trust
Good point.
nothing. I'm a statistician. I test everything, right? You give me a worker and you say, this worker is, their label is software engineer. And I go, great, I don't trust that. Let me see their code. Let me check it works for me. I'm not just going to trust them because they've got this label. Now, it's utterly nuts that someone would trust what's labeled artificial intelligence. Why would you do that? It's a term that people came up with in the 50s before they knew what they were talking about. There is no sci-fi here. It's incredible capabilities that you get when you are able to extract patterns from data at scale, and you've got the hardware to do that. Yes, the capabilities are incredible. I don't want to downplay them. This is a phenomenal UX revolution. But it's not a thinking entity. Not at all. It's just using an abundance of human-generated interactions and text that would boggle your mind when you think about it, so you can't imagine it as anything other than an entity. In the same way that evolution is very difficult to think about, because it boggles your mind to think about genetic change that's incremental. You don't think on those scales. So you don't think on the scale of how much information is actually powering a model like Lambda or any of the others. So where I'm trying to get to is this is a tool that a decision maker should use it responsibly and test the hell out of it. And all the problems that come up, and what I wrote about human gullibility. If you have a tool and you assume that this tool does something for you, and you never check, ever, whose fault is it? If somebody sold you that tool telling you, oh, it definitely does X, and then it doesn't, you'll send it back and leave an angry review. Of course you will. But if you trusted it before checking it, that's kind of on you as well. I mean, I'm going camping at some point. I ordered a new tent. It's on me if I never take it out of the box and set it up and actually check that it works before I take it where I need it. If it turns out that the tent doesn't work at that point, well, yeah, I'm going to be pretty mad at the manufacturer. But also, it's kind of on me for not checking, for just trusting. Don't trust anything. If it's mission critical, if it's really important for it to work, then you got to test that it does what you need it to do for you. If it's not important, then shrug it off, then just go with it. That's fine, right? If you're like, oh, I'm feeling capricious today, write me an email to my boss in the style of John Milton's Paradise Lost, right? That's just fun. We're just having fun. It doesn't matter if it works or doesn't. And I'll read it and amuse myself, and that's okay. But now imagine instead if what I said was write an email to, I don't know, my potential employer. I'm on the final stage of my recruiting process, and I'm not even going to look at it. I'm just going to send it. Come on. In terms of decision making, if it's that mission critical, please put yourself back in the loop. Have a look. Make sure you like what it's doing. It's built for something. It's not necessarily built exactly for what you want it to do. So always check. So check everything if you're going to build on top of these systems. If you're going to put them into your own apps, check. Now you have, again, what is your objective? What are you trying to do? How would you know if it works? What are your criteria for releasing and not releasing this thing? And you know who you need around for that is a statistician who's going to tell you, is this safe or is this not safe to use the way that you have specified? Now you've got all kinds of responsibilities as a decision maker. Specify the uses that you need. When and how is it allowed to work? What failures are acceptable? What failures are unacceptable? That's quite a lot of work put back on you. And if you're just like, no, it's a robot, it's great, it's got mathematics in it, it works. That's like me not trying my tent out. Who knows where my tent came from? My tent could have been put together by, college students who were 16 beers in, right? Like, I don't know where it came from. I'd better test the thing if I need to rely on it.
So true.
So it's about gullibility. It's absolutely about gullibility. We need to learn new standards of not being gullible. We need to understand that on the internet, unlike at least newspapers in the old days, some human was held accountable for something resembling quality. Tabloids maybe started pushing us away from that. Today, all kinds of things can go on the internet. So if you take everything that you see there seriously, that again is on you as a decision maker. A good decision maker would never do that. A good decision maker would verify. A good decision maker wouldn't trust without testing. So if you want to be a good decision maker using this thing, the way you phrased it right, should it make decisions for you? Why? Why would you allow a thing to make decisions for you? If you step in and you say, here is the decision process that I would like automated, here's how I'm going to check that it works, that's actually you making the decisions in advance and having a tool scale up your ability to do that. But you took control as decision maker. If, on the other hand, you're just like, it's a magic 8-ball, I don't care, I'm just going to do what it says, that's also you making the decision to follow that decision process. It's just a dumb decision process.
That's a very good. And you've talked also about where we are in terms of the job market concerns, regarding AI. You mentioned that back in the 70s, secretaries feared that they would be replaced by robots. Managers were absorbing many of those duties. So what are you expecting LLMs to cost people to absorb in the near and far future?
I continue to say that there is a lot of responsibility on the leaders to be very careful about those two lines. What does success look like? And which examples are we going to learn from? Now, on the other hand, if you are just using someone else's AI tools, when you use them as the tool making and tool using creature that you are, you may find creative ways to make yourself hyper efficient. And these tools allow individuals now to interact with systems that give them capabilities they wouldn't have had before. This is the big revolution, that I, as an individual, can now suddenly do things I didn't expect to be able to do, thereby boosting my productivity. So an example that I often use is I'm a blogger. I have quite a big blog on Medium. And people think that I am primarily a writer. I get such terrible writer's block when I look at the blank page. I can't get past it. But I'm pretty good at rambling, as everyone's managed to enjoy today. So for me, the much easier thing is to just ramble into a microphone. And then I would love for that to turn into a blog post, right? I still have the ideas, I still ramble, but now somehow wouldn't it be great if I didn't have to face that scary blank page? Well, with an AI tool, I can boost my productivity. I could, instead I could sit with like one of those old-fashioned dictaphones and play it back and then type it up. Or worse, imagine in those days with an ink and a quill, when the tools were even worse, I would have to, have my scribe write it all down or something. Now I can not only type it up and remix it on Computer's Cool, that I don't have to rewrite it all to fix a typo, but I can use speech to text to automatically go through what I've rambled into a mic and turn that into something that goes on my page. Now that is fundamentally a productivity boost for me as a writer. And before there was speech to text, I didn't have the option to work like that. So I would have to expect that I'm going to spend a day or whatever it takes to carefully transcribe my silly dictaphone recording. Now I get a whole day back because I can take whatever I've rambled and put it on the page automatically. And when I get a day back, that is me being more productive. I don't particularly want to type whatever's in my dictaphone out. I don't like that. What I want to do is get to thinking. And so the less time that I need to spend what I call thunking instead of thinking, just doing relatively mindless stuff that I don't even enjoy, the more I can get done. So I basically automate away a whole bunch of that stuff. And when I talked about the scribe with the quill and the parchment, that was a job that now goes away because I am able to speak, have that captured by a machine, have it turned into text by a machine that I can remix without employing any scribes with their quills in the middle. So yes, that has labor market impact because I individually have made myself so much more productive. And now let's think about all the other capabilities that we could allow me to get. So another one is illustrating my blog posts. So I used to go to Pixabay and use those relatively ugly, I apologize because it's a work from the heart Pixabay is, and I am very appreciative of it, but mostly ugly images there. I feel so bad saying this. And I used to use those nice royalty-free images. But now I'm capable of using Midjourney, for example, to generate pictures that look like what I had in my head when I was imagining how this piece should be illustrated. I didn't expect to have that capability as a statistician, as a decision-making expert, right? Like at what point was I learning about illustration? I wasn't. I'm not a professional illustrator. And yet I can take that on. So if I would have had an illustrator as part of my staff, I never did, but Pixabay was my illustrator. Thank you, Pixabay, for the many years of service. But had I had an illustrator on my staff, that would have been me as the boss taking on the illustrator's job. So an individual absorbing a lot of productivity, making themselves more productive because they have access to these tools, that's the labor market revolution. And if everybody had equal access, then everybody, all of humanity, would step up and we would be all more productive. We could start fixing the big problems. I get very impatient when people say, oh, there'll be nothing to do because AI. Would you look around you? You can tell me there's nothing to do when you've fixed all the problems, all the ills in the world, all the inefficiencies, all the potholes. When you've fixed all of them, when you've cured all the diseases, when you've invented everything that we need, when you're no longer wasting so much food while people are going hungry, right? Then you can say there's nothing to do. But please, while there is so much that we need to be working on in this world, what arrogance, right? Yes, we need to pivot and reorient. There will be upheaval because change is difficult. So the idea that there would be nothing for anybody to do is just plainly ludicrous. There is so much. I appreciate the difficulty of the upheaval, but I'm so excited for us to all step up. But that's a scenario in which everybody gets the upgrades.
So thank you so much for coming to the episode. And I just want to know there's a few places that we have where you can find out more information about the show. It's a LinkedIn page that you can subscribe to and be notified of news and changes, a newsletter with show notes, links from the episode, highlights, and more. There's a guide with past and future episodes, a YouTube playlist, and you can even listen to this as an audio podcast if you want to. Now, next week, we have Nick Singh. He's an interview preparation specialist for top tech companies. He worked as a software engineer for Google and a growth engineer at Facebook. And we'll be talking about some career strategies for an AI world. So once again, thank you so much, Cassie. Really appreciate you taking the time, and we'll talk to you soon. Take care.
It was a lot of fun to be here.